Hello everybody, hello. Hi, good afternoon, good evening, good afternoon. It's that time of the day when you are not sure whether you should wish good afternoon or good evening. So can everyone see me and hear me properly? Am I audible and visible, students? My dear kids, namaste, namaste. Good afternoon. So how is everyone? I am good. Hi everyone. Okay, great. All right. Good afternoon, everybody. Good afternoon. Hello to YouTube people as well. Offline classes will start very soon. Teddy bear, don't worry. Sir, aap kaise ho? I am good, beta. I am good. All right. Chalo, great. So, is everyone ready for the class? Today we will be starting with the fresh portion of stoichiometry. So, is everyone ready? Hello, everyone. On YouTube also, hi everybody. Hello. I can see some of the names. Too much light on my face. Okay, so Varshita, Asha, Reddy, Chakri. Good afternoon, everyone. And we have Dikshita here, M. Seva, Geetika, Supraja, Vishnuvardhan. Hi, everyone. Sri Lasya. Good afternoon. Good afternoon, Sudeshna, Shirley. Good afternoon, Omkar, Harshita. Everybody, good afternoon. All right. Had lunch? Yes, long ago. Yeah, it's 4 o'clock. Okay. Is this physics or chemistry? This is chemistry class, beta. Chaliye, so today, my dear friends, yesterday we revised about this thing, that is Y-map interconversion. So we revised about them. Now in today's class, we will be beginning with a fresh portion, that is stoichiometry, the next portion of mole concept chapter. Stoichiometry. Let's start with stoichiometry in today's class, guys. Very interesting and very important. Sir, ye to chai ka time hai. Yes. I started being a vector, sir. Yes. Naushika, well done. Okay, good, great. So stoichiometry is what we are going to cover in today's class. Now pay attention and focus. No more chats now. Listen to me very carefully now. What is stoichiometry? See, stoichiometry is simply a very fashionable name for analysis of a balanced chemical equation. Here we are supposed to do the analysis. And when I say analysis, it means quantitative analysis. Quantitative analysis means analysis involving numbers. All right. So here we are supposed to do the quantitative analysis of a balanced chemical equation. Now, first of all, let us start with the very basic fundamental level. Okay. What is a chemical equation, bacho? If I ask you that what is a chemical equation? Okay. So a chemical equation is nothing but a scientific shorthand representation of a chemical reaction on paper. Okay, how a reaction is happening, you try to write it on a piece of paper. Okay, so what you get is known as a chemical equation. Like, for example, yes, let's say a very common reaction between hydrogen and oxygen to produce water. Okay, so if I write this reaction, that is H2 plus O2 goes to H2O. So what is this equation telling us? That hydrogen and oxygen, H2 and O2, are reacting to produce H2O, which is known as water. Now, if you look at this particular chemical equation, this chemical equation is a unbalanced chemical equation. Please keep writing also simultaneously so that we can cover more examples. Okay, if you don't consume a lot of time in writing, so I write as such very less things. Okay, so H2 plus O2, everybody, goes to H2O. Now this equation is representing that hydrogen and oxygen are reacting to produce water, but this is an unbalanced equation. Now why am I saying this is unbalanced? Because in a chemical equation, in a balanced chemical equation, the number of atoms of every element should be same on both sides. Number of atoms of every element should be same on both sides. Okay, so hydrogen, you have 2 over here and hydrogen is 2 over here. So hydrogen is balanced, guys. But what about oxygen? Oxygen is 2 and oxygen is 1. So that is why it is not balanced. It is not balanced. Okay. Now, an unbalanced chemical equation does not give us a lot of information. It only tells us about the reaction, but it does not tell us any quantitative information like how much reactant, how much product. This we cannot know. From an unbalanced equation, we can only know what is the reactant and what is the product. But how much reactant and how much product, that cannot be interpreted from an unbalanced equation. So therefore now what we have to do is we have to balance this equation. This is unbalanced right now. So we have to balance it, guys. Now, if I ask you, boys and girls, that in the process of balancing it, H2 plus O2 goes to H2O. If I have to balance it, guys, okay, so hydrogen 2 is balanced, oxygen 2, but oxygen only 1 over here. So my question to you is that if I put 2 over here, then it becomes balanced. But is this correct? 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 No, it's not correct. It's wrong. It's wrong. Absolutely. Can you tell me why? What is the problem? What is the problem? What is the problem? If I have balanced it like this, what is the problem? Yes. The problem is that you have changed the reaction. In the process of balancing, beta, you are not supposed to change the reactant and products. Earlier water was forming. Now hydrogen peroxide is forming. These are not same reactions. Okay, so we cannot change the product. We cannot change the reactant or the product. So this form of balancing will not be accepted. This is wrong balancing. Okay. Yes. So now, in order to have 2 oxygen over here, okay, in order to have 2 oxygen over here, we will be putting 2 over here. So now once we put 2 over here, now oxygen is balanced. Now you have 2 oxygen. But hydrogen gets unbalanced in that process. Now hydrogen becomes how much? 2 into 2, 4. But here you have 2 only. So in order to balance it, you will be putting 2 over here. So this is known as balancing of a chemical equation. Now this is the correct balanced equation. Okay. This is the balanced chemical equation. Now a balanced chemical equation is a very, very, very useful thing. It not only tells us about the reactant and product, but also tells us about how much reactant and how much product. So from a balanced chemical equation, we can carry out quantitative calculations. From unbalanced equation, we can carry out only qualitative. Qualitative means just information, no calculation. But from balanced, we can carry out quantitative. All right. So now these numbers which you have used for balancing, the entire story in this topic. Sir, thank you. I didn't know about how to balance equation. Okay, Geetika, you are welcome. Okay, now listen to me carefully. Pay attention. Don't break the tempo. Okay, pay attention. This is very crucial. First, the way I teach, whenever I begin or start with any new subtopic or topic, the first 15 to 20 minutes are extremely important. Because there I will explain you the very fundamental basics of that topic, and after that we do lots and lots of problems to revise the concepts again and again. Okay, so please hear very carefully. Now these numbers which are used for balancing, bachcho, okay, here you have 2, where nothing is written. Where nothing is written means 1. If nothing is written means 1. Okay, and here you have 2. So these numbers which are used for balancing, where nothing is written means 1. Okay, these numbers which are used for balancing are given a very fashionable name. See, in this today's world, it's very important to be fashionable. Okay, you just can't come across as a normal human being. So if you want to leave a mark on the society, you need to be fashionable. So these numbers which are used for balancing, all right, are known as, they have a very fashionable name. They are called stoichiometric coefficient. So stoichiometric coefficient is nothing but a fashionable name for the numbers which are used for balancing. Stoichiometric coefficient. They are called stoichiometric coefficient. Yes. And the entire, you can say, the application of this topic is about the fact that what do these stoichiometric coefficients tell us? What information do they give us? What can we interpret by looking at these stoichiometric coefficients? This is the gist, summary, basis of everything in this topic. So let us go on to the next slide and try to understand what do they represent. What do they represent? Let us understand it on the next slide. So I believe everyone has noted it so far. CGGG. Sir, voice is low. Beta, please increase the volume of your device. My voice is at the maximum level. Can we write H2O? No. We cannot change the product. Everybody can hear me? Am I audible properly, guys? Because if some issue is there, then it will be for everybody at my end. So if you are facing some issue, then it is because of maybe any poor connectivity at your end. Chalo. So bhai, now listen everyone, please focus. So if I write that equation 1 again, 2H2, okay, 2H2 plus O2 goes to 2H2O. So beta, the stoichiometric coefficient 2, 1 and 2, what do they represent? They represent, see, in any chemical reaction, reactants are consumed and products are formed. Reactants are consumed and products are formed. So this 2 and 1 over here, the 2 and 1 over here, they represent that one molecule of O2 will react with 2 molecules of H2. One molecule of O2 will react with 2 molecules of H2. One molecule of O2 will react with 2 molecules of H2. If I take 1 dozen molecules of O2, then I will have 2 dozen molecules of H2. But in chemistry, counting is not done in terms of dozen. Counting is done in terms of moles. So it also represents that 1 mole of O2 will react with 2 moles of H2 to produce 2 moles of water. So basically, a balanced chemical equation, the stoichiometric coefficients represent the mole ratio in which reactants are consumed and the products are formed. Okay, this equation over here is telling me that if in some vessel, some container, hydrogen and oxygen are reacting to produce water, then for every 1 mole of oxygen consumed, 2 moles of hydrogen will be consumed and 2 moles of water will be formed. For every 1 mole of oxygen consumed, 2 moles of H2 will be consumed and 2 moles of water will be formed. So the stoichiometric coefficients represent the mole ratio in which reactants are consumed. Let's write down this important point. Okay. VVIP. Note. VVIP. Very, very important. In a balanced chemical equation, I will write in short form SC. SC stands for stoichiometric coefficients. In a balanced, in a balanced chemical equation, the SC, that is the stoichiometric coefficients, SC means short form for stoichiometric coefficients, represent the mole ratio in which reactants are consumed, and products are formed. They represent the mole ratio in which reactants are consumed and products are formed. This is the meaning of stoichiometric coefficient. Okay, SC stands for, I think I said it 5 times, Charan, stoichiometric coefficient. These numbers are called stoichiometric coefficient. Okay, in a balanced chemical equation, the stoichiometric coefficient represent the mole ratio in which reactants are consumed and products are formed. It is the ratio of moles and the ratio of moles which are getting consumed. It is that ratio, and the ratio of moles which are getting formed. And my dear boys and girls, who is getting consumed? Who is getting consumed? The things which get consumed are called reactants. And who is getting formed? Who is getting formed? Who is getting formed? Products. Yes, yes. So it is the ratio of moles of reactant consumed and the moles of product formed. Now, any problem of stoichiometry, like this equation is telling me कि भाई if 1 mole of oxygen is consumed, then 2 moles of hydrogen will be consumed. Now, any problem of stoichiometry is like the basic ratio and proportion problem which you did in your 7th, 8th or 9th maths class. I mean 7th, 8th or 9th class of maths. Okay, ratio proportion chapter everyone has studied. Ratio proportion chapter everyone has studied. All of you? First time maybe I think it comes in 6th or 7th class. Or at least once you must have heard the word. Na? Ratio word you have not heard in maths till 10th class. You have not heard the word ratio in your life ever. Ratio and proportion is a very basic chapter of maths. Everyone must have at least heard about it once. So I'm not asking that you have studied it. You must have heard the word. Chalo. So now listen to me. Very simple. Very simple. So every problem of stoichiometry is like a problem of ratio and proportion. In ratio and proportion chapter, we do these questions na, that ages of Ram and Shyam are in the ratio 2:3. Ages of Ram and Shyam are in the ratio 2:3. Ram is 10 years old. How old is Shyam? Ages of Ram and Shyam, no need to write it down, just explaining, no need for noting it down. Ram upon Shyam ratio is 2/3. Ram is 10 years old. So how old is Shyam? Ram is 10 years old. So how old is Shyam? So in place of Ram, I can put 10 years upon Shyam. This ratio is how much, beta? 2:3. 2:3. So 2 cancels this 5 times. 2 cancels this 5 times. And I get cross multiplying. Shyam is equals to 3 5s are 15. So ages of Ram and Shyam are in the ratio 2:3. Ram is 10 years old. So Shyam is 15 years old. This is the basic ratio proportion problem you might have heard for the first time in standard 7, 8 whenever you study ratio proportion. So my dear students, every problem of stoichiometry is like this only. This is the basis of any stoichiometry problem. ठीक है? देखो सुनो मेरी बात. Listen to me. Hydrogen and oxygen are getting consumed in what ratio? Hydrogen and oxygen are getting consumed in what ratio? 2:1? 2:1? Okay. Or if I say oxygen and hydrogen, then 1:2. Oxygen upon hydrogen, then 1:2. Oxygen is to hydrogen 1:2. Hydrogen is to oxygen 2:1. Now what kind of question they will ask you? Ki bhai reaction is happening. 10 moles of oxygen consumed. So how many moles of hydrogen consumed? Tell me. 10 moles of oxygen consumed. How many moles of hydrogen consumed? 20 moles. 20 moles. 500 moles of oxygen consumed. How many moles of hydrogen consumed? 1000 moles of hydrogen consumed. 250 moles of oxygen consumed. How many moles of hydrogen consumed? 500 moles of hydrogen consumed. 30 moles of hydrogen consumed. How many moles of oxygen consumed? 30 moles of hydrogen consumed. Then how many moles of oxygen consumed? Half, 15. 1000 moles of hydrogen consumed. How many moles of oxygen consumed? 1000 moles of hydrogen consumed. How many moles of oxygen consumed? 500. Now listen carefully. 1000 moles of hydrogen consumed. How many moles of water formed? 1000 moles of hydrogen consumed. How many moles of water formed? 1000 moles hydrogen consumed. 1000 moles water formed. 1000 ratio is 1:1. Arey 2 mole is giving 2 mole bhai. 2 mole is giving 2 mole. Hydrogen water ratio is 1:1. 1000 moles hydrogen consumed. 1000 moles water formed. 500 moles hydrogen consumed. 500 moles water formed. Understood everybody? 10 moles hydrogen consumed, how much water formed? 10 moles hydrogen consumed, how much water formed? 10 moles hydrogen consumed, how much water formed? And 10 moles hydrogen consumed, how much oxygen consumed? 10 moles hydrogen consumed, how much oxygen consumed? 5 moles. If 10 mole the ratio of hydrogen is to oxygen is to water is 2:1:2. 2:1:2. So all these answers which you have given now, fast. Each of them is one question of stoichiometry. Each of them is one question of stoichiometry waiting for you in the exam. This is the basis of stoichiometry. So far I hope you have got the feel of what is going to happen over here. Let's increase the bar. So far you have understood, okay, what's going on over here. Okay, let's move forward. Let's take this discussion forward. Okay, chaliye. Okay, great. So now suppose in stoichiometry for a general reaction, let us say AA plus BB goes to CC plus DD. Okay, this is a general reaction. Capital ABCD are reactant and product. Small ABCD are their coefficients, balancing numbers, stoichiometric coefficients. Okay. Now look at this reaction, beta, and tell me that if I write moles of A consumed, moles of A consumed upon moles of B consumed, moles of A consumed upon moles of B consumed, what will be their ratio? A moles and B moles consumed, what will be their ratio? Their ratio will be equals to A by B. A and B moles will be consumed in the ratio A by B. Equation number 1. Moles of A consumed and B consumed will be in the ratio A by B. Okay. All right. Moles of A consumed upon moles of A consumed upon moles of C formed. Moles of C formed. See, if it is reactant, then consumed. If it is product, then formed. Okay. So moles of A consumed upon moles of C formed. What is their ratio, guys? When A moles consumed, C moles formed. So their ratio, my dear students, is A by C. Equation number 2. Quickly note down these two equations, everybody. And finally, if I ask you that moles of A consumed upon moles of D formed. Okay, this CONS which I am writing, this stands for consumed. Upon moles of D formed. Moles of A consumed upon moles of D formed. What will be this ratio, everybody? This ratio, my dear kids, will be equals to A by D, equation number 3. Chaliye, very quickly, everybody, quickly note down these 3 equations. A by B ratio is A by B, A by C ratio is A by C, and A by D ratio is A by D. Okay, quickly note down these 3 equations. अरे डॉट कुछ नहीं है, ऐसे ही like we say na in maths यार कि this is equation number 1, nothing. dot is nothing. Okay, Sushant, nothing, it does not mean anything. Yeah, just to add some sound effect to the class. Dot equation number 1. Are everybody written? Very good. All right, lovely. Now tell me one thing I will write on the board. You don't have to note it down. Just try to understand. Suppose if I get a situation alpha is equals to beta. Suppose mathematically such a situation is coming. Alpha equal to beta, alpha equal to gamma, and alpha equal to delta. Alpha equal to beta, alpha equal to gamma, alpha equal to delta. So combining these three equations, can I say alpha equal to beta equal to gamma equal to delta? Can I say this? Yes or no? Alpha equal to beta, alpha equal to gamma, alpha equal to delta. So can I say alpha equal to beta equal to gamma equal to delta? Yes, of course. Very good. Well done, my champs. Good job. So I'll clean it. You don't need to write it down. This was just a logic test. Logic is important in life. Okay. Now look at the three equations which you have got. And in each of these three equations, just cross multiply. Cross multiply. So for one of them, I will write. For other two, you will have to just imagine it. No need to write it. So if you cross multiply, okay, bring this A over here and take this moles of B on right hand side. Okay. Ha beta. So once you do that, so see what will we get? Okay. So once you cross multiply, you will get moles of A consumed upon A. Moles of A consumed upon A is equals to moles of B consumed upon B. Isn't it, everybody? Moles of A consumed upon A is equals to moles of B consumed upon B. Okay. Cross multiply. Moles of A consumed upon A is equals to moles of B consumed upon B. Cross multiply. Okay, everybody? Moles of A consumed upon A is equals to moles of B consumed upon B. Now, for equation 2 and 3, mentally visualize a similar step. Visualize, no need to write it. Moles of A consumed upon A is equals to moles of B consumed upon B. For equations 2 and 3, mentally visualize a similar step. Okay, so what will you get over here? Moles of A consumed upon A is equals to moles of C formed upon C, and moles of A consumed upon A is equals to moles of D formed upon D. My dear boys and girls, are you able to realize that left hand side will become same for all the three equations? Moles of A consumed upon A, 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 moles of A consumed upon A. Alpha equal to beta, alpha equal to gamma, alpha equal to delta. So combining all the three equations, moles of A consumed upon A, moles of A consumed upon A, moles of A consumed upon A is equals to, pay attention now, moles of A consumed upon A, moles of A consumed upon A, moles of A consumed upon A is equals to moles of B consumed upon B. Moles of B consumed upon B, moles of B consumed upon B is equals to moles of A consumed upon A is equals to moles of C formed upon C, moles of C formed upon C. Okay, moles of C formed upon C is equals to moles of D formed upon D. So this is the basic equation. For an equation of the type AA plus BB goes to CC plus DD, we can write moles upon stoichiometric, moles upon stoichiometric, moles upon stoichiometric for equal to for all the reactants. Okay, beta, if you cross multiply, first of all, I would personally like to address only those doubts who join with their actual names. If you join with teddy bear, funny guy, cute girl, so see, this shows that you could be some fake person who is just wasting the time of the class. So it is humbly requested that all of you, if you join with a proper name, then of course we can discuss once again. So if you look at the three equations, I'll explain it once again. Everybody pay attention, all of you. So I simply said that these were the three equations. Now if you cross multiply in them, okay, so moles of A cross multiply means bring this over here and take this over here. So moles of A consumed upon A is equals to moles of B consumed upon B. Moles of A consumed upon A is equals to moles of C formed upon C. And moles of A consumed upon A is equals to moles of D formed upon D. So if you cross multiply, bring this A over here, then left hand side is becoming same na bhai in all the equations. In all the equations you are getting moles of A consumed upon A, moles of A consumed upon A, moles of A consumed upon A. So moles of A consumed upon A is equals to moles of B consumed upon B. Okay, moles of B consumed upon B is equals to moles of C formed upon C is equals to moles of D. Abhi I told you na, if alpha equal to beta, alpha equal to gamma, alpha equal to delta. So all four of them will be what equal? Alpha equal to beta equal to gamma equal to delta. So moles of A upon A, moles of B upon B, all these four quantities will be equal. So for any balanced chemical equation, we can write such a relation. And this equation, I personally call it as the grandpa equation. This is name given by me. This equation which we write, I like to call it as the grandpa equation. Now you'll ask me, sir, why? Ask, sir, why do you call it grandpa equation? What is the logic? See, as kids, when we were very inquisitive, curious, we used to ask lots of questions, right? Sometimes very stupid ones also. And then who was the person to whom we used to go for our answers? Most of the times, we used to go to our grandpa, Dadaji. Dadaji to answer all our silly questions. Okay. So this is the grandpa equation of stoichiometry, which has the answer to all the questions of stoichiometry. So this is that particular equation which will answer each and every question of stoichiometry. And what will be the basic pattern of the question? Beta, information about any one of the reactants or products will be given. Like they will say, ki bhai, this much B consumed, so how much C formed? This much D formed, so how much C formed? This much C formed, so how much A consumed? This much A consumed, how much D formed? So information about any one of the reactants or products will be given, and for the others you will have to calculate. So at the end of the day, stoichiometry is nothing but a basic question of ratio and proportion. And now our theory is complete. Let us start practicing one by one, lots of problems. Ready everybody, all of you? This is the grandpa equation. Lots of applications based on this grandpa equation. Okay, lots of applications based on this grandpa equation. This is the basic fundamental logic of any stoichiometry problem. Good, very good. Of course you should note down the grandpa equation. This is very important. So first of all, let us apply the grandpa equation. Let us learn how to write the grandpa equation for some reactions. Suppose, this is noted everyone, I hope you all have noted it down. So how will we apply the grandpa equation, guys? ठीक है, देखो, suppose I tell you an equation is there, 2KClO3. What is the basic form of grandpa equation? Moles upon stoichiometric is equals to moles upon stoichiometric is equals to moles upon stoichiometric for all the reactants and products in a balanced chemical equation. Moles upon stoichiometric are equal for all the reactants and products in a balanced chemical equation. If it is a reactant, then moles will represent moles consumed, and if it is a product, then moles will represent moles formed, because eventually it is the ratio of consumption and formation. So now, my dear kids, suppose I give you this equation, 2KClO3 on heating, this delta sign, triangle sign delta, it is called delta, it means heating, goes to 2KCl. Acha, before applying grandpa equation, we should always check whether the equation is balanced or not. Okay, so 2KClO3 goes to 2KCl plus 3O2. So if you have to apply grandpa equation for this, then what will you write? Moles of KClO3 consumed upon 2 moles of KClO3 consumed upon 2 is equals to moles of KCl formed, moles of KCl form upon 2 is equals to moles of O2 form upon what? Moles of O2 form upon what? Upon 3. Okay, moles of O2 form upon 3. Bas, that's it. Chalo, let us practice some problems now. Moles of KClO3 consumed upon 2 is equals to moles of KCl formed upon 2. Moles upon stoichiometric equal to moles upon stoichiometric equal to moles upon stoichiometric for all the reactants and products. If it is reactant, then consumed. If it is product, then formed. And yes, we should check that the equation is balanced or not. That is very, very important. Then only grandpa equation will apply. Chaliye bhai. So let us have a look at some questions. Okay. Chalo, come on everybody. First problem. Let's have a look. First question. Let's have a look. Same equation I will take. 2 KClO3 goes to 2 KCl plus 3 O2. Okay. Find the volume of O2 gas produced. Find the volume of O2 gas produced at NTP. I told you yesterday NTP, STP almost same. Find the volume of O2 gas produced at NTP by 10 moles of KClO3. Find the volume of O2 gas produced at STP by 10 moles of KClO3. Now listen to me everybody. Listen to me everybody. Data for KClO3 is given and data for O2 is asked. So KCl is not needed over here. KCL का कोई role नहीं है. KCl does not have any role in this question. In this question, it does not have any role. Otherwise, it has a role in the reaction. Okay. So we will apply grandpa. We will apply grandpa on KClO3 and O2. Once we apply grandpa on KClO3 and O2, I will write moles of KClO3. Of course, consumed. There is no need to write consumed every time. It is understood it is consumed because it is reactant. Okay. Moles of KClO3 upon step by step. No hurry. Moles of KClO3 upon 2 is equals to moles of O2. Moles of O2 formed. O2 will be formed because it is product upon step by step. यार कोई जल्दी नहीं लाइफ में. Be very relaxed. When concept formation stage is there, be relaxed. No hurry. No hurry. So divided by 3. Okay, bhai everyone. Chaliye. Moles of KClO3 beta. We can put what over here? Moles of KClO3 we can put what over here? How many moles of KClO3 consumed? 10 mole. 10 mole. So I will put 10 over here. Divided by 2. 10 moles of KClO3 is consumed. So I will put 10 over here. Is equals to moles of O2 upon 3. Ram and Sham question aa gaya na? Question is Ram and Sham logic or not? Question is Ram and Sham logic. Everybody understood, all of you? Chaliye. Okay. So 2 gets cancelled this. 5. So moles of O2 is 3 into 5. 3 into 5, 15 mole. So my dear boys and girls, 15 moles of O2 will be produced. From 2 moles, we are getting 3 moles. So from 10 moles, we will get 15 moles because ratio is 2:3. So 15 moles of O2 ka volume we have to calculate. How can we do that? 15 moles O2 ka volume we want to calculate. How can we do that? 1 mole is equals to 22 point. Yes, very good, Pranati. 15 moles O2 ka volume at NTP we have to calculate. How can we do that? Into 22.4. Lovely, 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 guys. So volume of O2 will be equals to 15 moles and this is the volume at NTP. 15 moles into 22.4 liter per mole. This is the volume of 1 mole. So mole cancel, cut to mole cut to. What do we get? 15 fours are 60. Carry over 6. 15 twos are 30 and 6, 36. Carry over 3. 15 twos are 30 and 3, 33. And 1 decimal also. So 336, capital L, which stands for liter. 336 liter. Well done, boys and girls. Very good, very good. Lovely, 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 lovely. Good, good, good. Awesome, awesome, awesome. Ready for next problem, everyone? Ready for next problem, everybody? Satakshi Rai says interesting, sir. Thank you, thank you. Okay, chalo, next question. Next question. Okay, very good. Next question. Which calculation? अरे this is so चिन्ना calculation यार. इसमें क्या explain करना है? 15 into 22.4. 15 fours are 60. 0. Carry over 6. 15 twos are 30 and 6. 36. Carry over 3. 15 twos are 30 and 3. 33. If you are not happy like this, you can do like your usual self. 224 into 15 ऐसे करके देख लो बेटा. Do like this if this gives you happiness. But once you start studying from me, you will get used to doing calculations like this. Okay, chalo. Next. Quickly. Next is N2O5 solid goes to 2NO2 gas plus half O2 gas. Okay, N2O5 solid goes to 2NO2 gas plus half O2 gas. Find the volume of, or let's say this time we will calculate mass. Find the mass of NO2 gas. Find the mass of, अच्छा, in case you are carrying this false, wrong concept, or should I say misconcept, from maybe from standard 9th and 10th, that stoichiometric coefficient always needs to be a whole number, it cannot be fraction. That is absolutely wrong. It is very much possible, it can be, eventually it is a ratio. So even equations can be written like this. By this is telling me 1 mole of N2O5 is giving me 0.5 mole of O2. What is the problem in that? 1 mole of N2O5 is giving me 0.5 mole of O2. It is perfectly correct. And this equation is balanced. Please check. 2 nitrogen, 2 nitrogen. 5 oxygen, 2 nitrogen, 2 nitrogen. 5 oxygen and 2 twos are 4. 2 twos are 4. And 1 by 2 into 2. 1 by 2 into 2 is 1. So 4 plus 1. 5 oxygen and 5 oxygen. This is a balanced equation. Okay. So stoichiometric coefficients can be fractional also. There is no rule as such that they need to be whole number always. Okay. This need not be the case always. Okay. It can be fraction. So find the mass of NO2 gas produced. Find the mass of NO2 gas produced from 2.16 gram of N2O5 solid. 2.16 gram of N2O5 solid. चलो everybody try this problem. हाँ ऑफ कोर्स यार, नेगेटिव कैसे आएगा अभियुक्त? ये तो अंडरस्टूड बात है यार, मोल नेगेटिव थोड़ी ना होगा. पॉजिटिव इंटीजर्स, यस. It cannot be coefficient. Why will it be negative? Okay. Chalo bhai. Quickly solve it, everybody. Do states of reactants and products affect what? States of reactant and product are just given for additional information, bhai. If I ask you to apply the Satakshi, if I ask you to apply the 22.4 liter concept, then that is for gases only, no? So it is just written to make the reaction more informative. Okay. हाँ. चलिए तो भाई, first of all, your first step would be, see, for the reactant this time mass is given. So our first step should be to calculate the moles of reactant. Our first step should be to calculate the moles of reactant. Okay. So we will be doing moles of N2O5, moles of N2O5 first. Moles of N2O5 निकालेंगे. First we will calculate moles of N2O5. Moles of N2O5 will be equals to given mass upon molar mass. N2O5 molar mass beta 16 5s are 80 plus 28. 80 plus 28 is 108. Okay. So it is 108 gram per mole. Now 108 will cancel this how many times? 108 will cancel this 2 times. 108 into 2 is 216. And 2 decimals are also there. So I will be writing 0.02 mole. This is the moles of reactant. Because over here the moles of reactant was not given. Okay. So first we calculated the moles of reactant. Okay, everybody? Moles of reactant we calculated first. And now information about N2O5 is given. Information about NO2 is asked. So I will apply grandpa. on N2O5 and NO2. So let us apply grandpa equation. So moles of N2O5, of course consumed upon 1. Look at the coefficient. Moles of N2O5 upon 1. Okay. Yes, Muhammad Ali, abhi I'll check. Okay, is equals to moles of NO2. Of course, it is formed only. It is understood. Product means formed only. Moles of NO2 upon 2. Moles of NO2 upon 2. Now, in place of N2O5, we calculated moles of N2O5 0.02 beta. So we will put 0.02 over here upon 1 is equals to moles of NO2 upon 2. So moles of NO2 formed, moles of NO2, it is product, so it is understood it is formed, is 0.02 into 2. So 0.02 into 2 is 0.04 mole. But I am asking for mass of NO2. So mass of NO2, what will you do by everybody? Mass of NO2 you will multiply by the grandpa equation should be used in terms of moles, Bhavya. Only for moles, not in terms of mass. So molar mass we will multiply. So mass will be equals to mass of NO2. Mass of NO2 will be equal to 0.04 mole. 0.04 mole multiplied by the molar mass of NO2. Molar mass of NO2 will be 16 2s are 32. 32 plus 14, 46. So this will be 46 gram per mole. 46 gram per mole, molar mass. So mole cut 2 and 4 6 are 24. Carry over 2. 4 6 are 24. Carry over 2. And 4 4s are 16. And 2 18 with 2 decimals. 2 decimals. So 1.84 gram is the final answer. 1.84 gram. Well done, boys and girls. 1.84 gram. Nand Kishore Naidu, in the place of grandpa equation, can we use unitary? You can use it, Nand Kishore beta, no problem. It is unitary method only. But I think if you start sticking to this logic, then I mean later on also you will benefit a lot in the topic of limiting reagent and all. Okay. Chalo, previous slide, those who are writing down. Test for paper. So abhi I don't have the paper right now with me. And anyways, test paper discussion is, I mean, not a part of the agenda because like I have to teach other things, but still let me see if I can get the paper. One more question we'll do quickly. So those who are writing, quickly note it down. Okay, Shiva, I will get back to you. Abhi I mean, from morning onwards I had classes, so I could not get hold of the paper, but don't worry. If not now, then once you are here, you can discuss that. Don't worry about that, beta. Every doubt will be cleared. Each and every doubt will be cleared. Don't worry. We will teach you so much. We will clarify so many of your doubts that you will yourself say, okay, sir, leave us now. Let me. Enough. I have prepared enough. Okay. You will say, sir. बस अब सर और मत पढ़ाइए सर, बहुत हो गया सर, बस हो गया सर. Don't worry about that. ठीक है, to that extent we'll teach you. All right, ready for one more question, kids? Don't worry, Shiva. Chalo, very good. One more question quickly. So question is that find the volume of Cl2 gas. Find the volume of Cl2 gas consumed at NTP to produce 73 kg of HCl. Find the volume of Cl2 gas consumed at NTP to produce 73 kg of HCl. Reaction given is H2 gas plus Cl2 gas goes to 2HCl gas. Hydrogen atomic mass is 1. Chlorine atomic mass, you know. Chlorine atomic mass. Hydrogen atomic mass is 1. Chlorine atomic mass is fractional. Yes. Chlorine is 35.5. Maybe sir might have told you why it is fractional. If not, then don't worry. You will be studying this once you are here. I'm not sure whether sir has covered that concept or not, but anyways, it hardly makes a difference. Average atomic mass. So if you know about it, then very good. If not, then I mean, these are just gift classes to tell you about the basics. So anyways, once you are here, we'll be starting from very fundamentals. So that will be covered. Don't worry. But if you know about it, well done. So hats off to Ajay sir who covered this concept. So H equal to 1, chlorine 35.5. Chaliye, solve. 73 kg of HCl produce करने के लिए how much chlorine will be consumed? Beta, it is kilogram. My dear friend Nihal, this is not gram. Kilo means 1000 gram. Kg means 1 kilo. Kilo means 1000. Chalo, answer, let's see. Nihal, you are doing it right, but just be a bit more careful with your calculations. .8 meter cube, no. Give me the answer in liters. 22.4 liter, no. 22,400 liter, Nand Kishore Naidu, 22,400 liter. Yashwant, 224 liter. Lakshmi, 44.8 liter. Give me the answer in liter. 44.8 into 103. 22,400, Sudeshna also. 22,400, Harika. S. Naushika, 22,400 liter. Ramya Shri, 22.4. Harini, by mistake, I think you have typed 22,300. You mean to say 22,400. Joshika Priya, 22,400. Digvijay, 22,400. Anya Sharma, 224. You forgot 10, I guess. 22,400 is well done, my dear students. Very good. Good. If you can believe me, if just after your class 10th exam with 2 to 3 weeks of chemistry class. If you can do this question, okay? Trust me, I have said this from the bottom of my heart, kidney, pancreas, liver, everywhere. Nobody can stop you from becoming a doctor. Okay? Nobody can stop you from becoming a doctor if you are able to think this much after 2 to 3 weeks of classes. If you can solve this question, then from the bottom of my heart, I am saying this, from the bottom of my pancreas, kidney, liver, intestines, everywhere. Sudeshna, yes, I can see your video, don't worry. So nobody can stop you from being a doctor. Trust me, if you consider me even little bit qualified enough to make any predictions, then my 15 years of teaching experience so far, if you can think this right after your class 10th and in 3 weeks of classes, Ramcharan beta, have patience. Okay, chalo, you have attended the classes, all the classes till now, Ramcharan? You have attended each and every class of chemistry till now? Answer me honestly. Each and every class. You have not missed a single class. All right, so what we will do over here is, I'll explain you, don't worry beta. So first of all, we will calculate moles of HCl. Moles of HCl, my dear bachcho, will be, so those who have missed some of the classes, don't worry beta. Once you are here, we will start from the basic level. Moles of HCl will be given mass by molar mass. So given mass is 73 into 1000 gram. Beta, kilo stands for 1000. 73 into 1000 gram upon molar mass is 36.5 gram per mole. Given mass by molar mass. So gram cancel, 36.5 cancels this 2 times. So I get the answer 2000 mole. 2000 mole. That's it. So if HCl is 2000 moles, then how many moles of Cl2? So moles of, we will apply grandpa on Cl2 and HCl. Cl2 upon 1 is equals to HCl upon 2. Okay. So HCl is 2000 beta. So moles of Cl2 will be equal to 1000 mole. HCl will be 2000. So HCl is 2000. So Cl2 will be 1000. 1000 moles of Cl2 will be consumed. So 1000 mole of Cl2, what will be the volume? 1000 moles into the molar volume, which is 22.4 liter per mole. So mole cancel and you get the answer 22400 liter. 22,400 liter. 22,400 liter is the answer. Okay. All right. Chaliye, so that will be all for today. Those who are writing it down, quickly note it. And I'll very quickly share the QR code as well. And we will meet once again in the next class. Great performance by all of you today. Really happy, really impressed, to be honest. And just keep up the good work, guys. You are on the right track. You have already become a vector. Okay. With the right direction. And once the direction is right, then you just need to keep on increasing the magnitude gradually. Don't increase it too much in single shot. Gradually, step by step, but make sure that the direction should be correct all through this while. Okay. So you are already a vector in the right direction. Just keep on increasing the magnitude step by step every day. S. Naushika, crystal clear class. Thank you so much. Thank you everybody. All right. So I'll see you tomorrow. Till then, bye-bye. Take care. Have a great evening, everybody. We'll continue from here in the next class. Okay. Chalo, bye. Enjoy your class with Vishal sir now. Okay, guys. Bye. Bye, everyone. Thank you, everybody. Thanks a lot. Bye, everyone. Bye.